our recent initiatives. One is in the area of public horticulture internships, and we have been working with APGA and a website called internships.com. I have the page up here. This is our landing page. We've launched a new partnership site specifically for internships in horticulture. So this is something that APGA had been struggling with. They used to publish an annual internship guide. The last time they were able to publish that was in 2006, just because of the cost and the challenge of keeping information up to date. And so we partnered with APGA to provide this website as a way that gardens and other public horticulture institutions can keep their own content up to date, and students can find those internships. So it's really going to streamline the matching process for horticulture internships. Some of the main advantages for students: if you're a student looking for an internship, you can create a profile so that employers can find you. There are also a lot of free tools and resources for resume building and tips on interviewing and things like that. And then from the employer standpoint, as a public garden or other public horticulture institution, you can fill out your own organizational profile, and instead of waiting for people to apply for your internships, you can actually search all of those student profiles, and there are tens of thousands on this site throughout the world. So you can actively, search and find your own candidates for your internships and let students know about your opportunities rather than wait for them to come to you. So that address is at the top of the page there, internships.com/group/horticulture, and I'm happy if anyone would like more information about that. I'd be happy to talk during one of the breaks. The other thing that we're working on conference week this week is the launch of a new professional section within APGA targeted towards emerging professionals. So students, recent graduates, and people that are relatively new to the field of public horticulture. We're launching this as a new official public professional section within APGA at the conference this year to develop some resources and activities. A lot of it is about building your professional network, especially for people starting out in the field. So we'll be launching that this week at the conference. So for those of you that are attending, I encourage you to come to that section meeting. It's on Thursday afternoon. And those of you not attending the conference, feel free to contact the center, contact me for more information if you're interested. Today's workshop is the second that we've done in partnership with Brian and UC Davis. And we did one in the fall that was very successful, same setup. And I want to just run through the partners that have supported that workshop, particularly UC Davis. This has been a great partnership in terms of Brian's development of the model. And thankful to Mia Ngolia from UC Davis for being here today to assist, and also Angela Lee from Esri, the developers of the GIS software. And this, in terms of the Center for Public Horticulture's involvement through UD, this came about through a grant that UC Davis was able to secure from IMLS, the Institute for Museum and Library Services, to promote this GIS model around the country to public gardens. So Brian has presented this at a couple of the recent APGA conferences, and then we're fortunate to be a new training partner with UC Davis to offer this. So with that, I would like to introduce Brian Morgan. He is we found out about Brian through UC Davis. I'm not sure if you're still affiliated with UC Davis.
I am,
correct?
yes.
Okay, yeah. He's also currently at Arnold Arboretum of Harvard University as a Putnam Research Fellow. So that's why I wanted to double check and make sure you're still with UC Davis. So he's with UC Davis, but also currently at Arnold Arboretum. So Brian, thanks for coming down. And Brian developed this model, so you're not going to find a better instructor for learning how to use it. And I think it's a great tool. So Brian, I'm going to turn it over to you. Thanks.
Right, thanks. Good morning, everybody. How's it going? Everybody get enough food? Everyone's fed and ready to go? All right. So I guess the first thing I'd like to do is kind of, I'm horrible with names, but I'm going to try my best. I'd like to go around and have everyone kind of just, introduce yourself and say where you're from, and maybe just say just a few words about maybe what you're trying to get out of the workshop or what you're hoping to do with GIS, so I can kind of understand, how to direct things today a little bit. So why don't we start with you?
Good morning. I'm Louise Clark. I'm with the Morris Arboretum from the University of Pennsylvania, and I manage one of the sections there. I'm interested in the software, see what it can do, and perhaps its application to the Morris Arboretum.
Cool.
I'm Shannon, and I have worked with Morris Arboretum as well. I'm also with Bowman's Hill Wildflower Preserve, and I'm familiar with like BGMap and BGBase, so I'm interested in how this works for garden mapping, kind of, as another alternative to that.
I'm Mike Gross from Georgia Park University in Lakewood, New Jersey, and we have a small arboretum, and I have a very dinky budget, and our records are GIS or GPS based, and I'm trying to figure out how I can use the database that we have and incorporate GIS into it.
Bill Hannis, Director of Field Operations at Fall Tree Operating Gardens in Elkgrove, Indiana. No one's ever heard of it yet. We're working on it.
I've heard of it.
I am our entire GIS department, and I'm really interested in working with the garden model.
Great.
Hi, my name is Graham Davis. I'm with Smithsonian Gardens. I was initially hired as an IPM specialist, but then we just completed a tree inventory, so I was tasked to see if we can make the data model work with our trees.
Nice to put a face with the name.
Yeah.
I'm John Rothling with Lakewood University, which has a campus-wide arboretum. The first person that's hired to manage this arboretum, so the whole goal is to start out on the right foot. I've worked with everything from no mapping to mapping by hand, having this technology, just being the only staff. It's going to make it, I think, a bit easier to start out this way.
Why don't we go all the way back to the corner?
I'm Steve Wright from Shannon Arboretum. I've been asked to digitize our maps, which are all just paper maps. So this is one of a handful of options.
And we're not specifically covering how to digitize paper maps today, but if we want to have a side conversation about it, I could give you a few pointers if necessary. Go ahead.
My name is Mike Startup. I'm a horticulturist at Haverford College Arboretum. We're working with BGBase currently, inputting data and looking at this as an alternative to BG Maps, or just want to weigh out the option.
Great.
I'm Martha at Artsdale, and also with Haverford College, plant curator, so I'm the one who collects all the data. Have it available for the horticulture.
I'm Gerald Dillon. I'm a architect. Just interested in learning about GIS.
Great.
My name is Aaron. I'm from the University of Ontario.
I'm sorry, I missed you there. Where are you from?
University of Guelph.
Got it.
We're just looking at various options to increase the profile, bring the collection in more accessible.
My name is Raul Puente. I'm the curator of the living collections of the National Botanical Garden in Phoenix, Arizona. And we are, like some of you, using beach-based and beach maps, so we're looking at switching to GIS as another option, perhaps more economical.
And back row there.
Kate Bell, a recent graduate of the Long Graduate Program, just looking to gain new skills to help me in the job market.
And I think you guys have all been introduced there in the back, so we'll move on. Before I go any further, is the recording stuff all happening? Is that working?
Now we're going to have to work that out.
Okay, well, the good part is that we recorded this session last time, and I haven't changed it a lot, so we'll probably be all right. Yeah, I think we'll be all right. Yeah. So I don't necessarily, this mic doesn't matter if it's working or not, right?
As long as can everyone hear Ryan okay?
Am I speaking loud enough for everybody? How about you guys in the back? You guys can hear me? Excuse me. You can hear me okay? Great. All right. Well, let's move forward here. So I'm going to start today with kind of a little bit of introductory background material to kind of bring you up to speed. I realize that there's some people who have a little bit of GIS experience, some don't have any, so we'll try to get everybody kind of on the same page. And essentially, we're going to start at a really basic level, and then we'll walk through a few steps to kind of how to download the data model, how to install it on your computer. How to start adding things to it, add some photos to it. We'll draw in some base map features, which are kind of like background ancillary information. We'll put some plants on there, and then we'll learn how to basically check stuff out to a mobile device. We're going to kind of do a simulated checkout by using the same software that runs on a mobile device on our desktop computers. And then we'll check some edits in that we've made that in our simulated field collection. And then we'll try to make a kind of really simple collection map. So we're going to walk through the whole process, hopefully. And the main goal of today is really to kind of expose you guys to all the different things. And we don't expect you to be able to absorb everything that you're going to get, but that's why we're video recording all this, and we have my presentation will be available online. So keep that in mind as you're going through this, and you can limit your note-taking if you'd like, because we will have this stuff available to go back to reference. So again, main point is to expose you to all this stuff, show you the steps, so that when you get to doing it yourself, and be like, oh, I remember that we did that, go back, look at the video, figure out how to do it. So hopefully that'll work out well for everybody. So the agenda for today is we're basically going to start with a little introductory presentation about what is GIS, and then we'll actually start up the GIS software, ArcGIS desktop, and we'll go through a really brief tour of how that program is laid out and some of the main features and functionality that it has to offer. After that, we'll do kind of an introductory presentation to the Geodatabase. The Geodatabase is basically a storage format for GIS data. Think of it as a container that holds all your data. And then I'll talk a little bit about what a data model is and introduce the one that we've developed. We'll take a little break, let everybody recuperate from that. And then after that, we'll go into more of an interactive kind of workshop style set of content. So we'll learn how to download the data model, install it on the computer, and then once it's installed, we'll give you a tour. I'll show you the different things that are that the data model contains, what you can map at your garden with it. And then we'll go through the steps that it requires to add aerial photography. So aerial photography is a really good kind of background to working with the GIS. You can get really high resolution aerial photography these days that you can see a lot of the features on the ground, and usually those photos are taken when the leaves are off the trees, so you can generally see quite a bit. So we'll learn how to add those photos into the Geodatabase, make it part of the data model. And then after that, we'll use that photo to basically digitize some features. So we'll use the photo as a backdrop. We'll go through and we'll trace some different things and start to create meaningful information in the GIS from what we can see through the photo. Then we'll take a lunch break. And Vic, is lunch on our own today? Is that how we're working it?
No, we have box lunch.
Oh, we do. Okay, great. So we'll have an hour for lunch. And then when we come back from lunch, we'll go through the steps required to digitize plant data, which is probably the meat for most of you guys, is what you guys are probably looking to do with it. So we'll spend a decent amount of time on that and really focus on how the data model is designed to be able to map plant features and relate them to one another. And then we'll go through that simulation that I mentioned of trying to collect data in the garden. So we'll learn how to take what we see on our desktop software environment and check it out so that we could use it on the ArcPad software, which is the mobile version of ArcGIS, essentially. So we'll go through those steps. We'll do some simulated data collection. Because we don't have 15 or 20 GPS units, we're not going to be able to go out in the field and do it, but the same software runs on this desktop, on our desktops here, so we'll be able to learn how to operate that at least and simulate doing some data collection. And then we'll check that back in, and hopefully we'll see all those changes that we made out in the field on our desktops. And we'll take another break, And then after that, we will go through the process of taking all the information that we've kind of created today and make a collection map out of it. It'll be really basic. And most people generally at gardens will do what we call map books, so you have multiple pages of maps for different areas of your garden. We're not going to have time to go through, obviously, creating a whole map book, but we'll do one page, and I'll kind of mention some of the things that are required to make a multi-page book. And then we'll have a little wrap-up and present a little bit more information on what you guys can do next, resources for next steps, and other things to help you get going as you start doing this at your own garden. So as I mentioned, really the goal of this workshop is to focus on basic concepts and skills, and we're going to go through learning about Geodatabase and the ArcGIS public garden data model that we've been working on for the past few years. And then we're going to, the skills that we're going to be focusing on today is what's called heads-up digitizing, which is basically taking an aerial photograph or some other kind of reference information and drawing in things on the screen. So that's just one form of data collection. There's also, you can go out and use a GPS unit to do that, or you can do traditional surveying to collect your data. So there's lots of different ways. We're going to focus on heads-up digitizing, but we'll allude to those other techniques as well. And then, as I mentioned, we're going to do a little bit of that mobile device data collection, a kind of simulation of that, and then we'll create a plant collection map at the end. So the first part of this presentation is really to kind of give you a background about what GIS is. So GIS is really focused on geography. That's where it came from, and it's in the word Geographic Information Systems, or in the acronym. And it focuses on really what is where, why is it there, and why do we really care about it. So a really interesting statistic that I found, and I've always tried to find a source for this, but it's just all over the internet, is about 80% of data has a spatial component. So, a lot of places have databases, and they're not necessarily the most friendly thing to work with. It's not very visual, and for those of us who are visual people, it's not really easy to extract meaningful relationships out of that. So GIS gives you the power to visualize about 80% of that database data in a map format. Which is a lot more appealing to at least me. I like to be able to see things and be able to discover spatial relationships between things. So the formal definition of GIS is basically it's a system of computer software, hardware, and importantly, personnel, the people who operate this stuff, are all part of GIS. And the goal of it is to help manipulate, analyze, and present information that's tied to a spatial location. Common misconceptions is that GIS and GPS are the same thing, but GPS, Global Positioning System, is a technology that can collect data that we can use in our GIS system. Another important thing is that GIS is not a map. So a map that comes out of a GIS system is not really a GIS. GIS is the whole system and all those pieces that make it, but a map is an output that we can create. And GIS is also not a software package by itself. So the software ArcGIS Desktop is not GIS by itself. It's like we need the data and we need the people to make that system really complete. So as I mentioned, it's a method to visualize, manipulate, and analyze and display data. But a really good way to think about it is they're kind of like smart maps. So basically, our GIS links visual information or a map to a database. And as I mentioned, databases are hard to interpret, but maps a lot easier to worth 1,000 words. And GIS is really neat because it can combine data from many different sources. You guys may have heard this kind of buzzword on the internet about mashups. I don't know if you guys have heard that before, but the basic idea is that you're taking information from all these different sources and putting it together all in one spot. So GIS is set up in the kind of the format of layers, where you can layer different kinds of disparate information on top of one another, and that can be a really powerful thing to be able to do that. So GIS data comes in two primary formats. One is called vector, which is essentially points and lines and polygons, and the other one is raster, or image data. In vector features, you basically, we use vector stuff to basically digitize things on a map. So when we're doing our digitization today, we'll use an image, which is a raster, as our background. And then we'll draw in, we'll trace things on the map, and those things will be vectors. So things like a house or a lake would be digitized with a vector feature. And each one of those features would have attributes tied to it. So this is where the database comes in. So you see the house or the lake on the map, but behind that we have a database that stores information about that house or about that lake. So you may have things like size, what type is it, how long is it, things like that. And then aerial, raster information is, as I mentioned, aerial photographs or other images that we keep in our database. GIS data can come from lots of different sources. As we mentioned, digitize and scan maps is one really primary format. So taking your old paper information and putting that into the GIS. A lot of people will take data from a CAD system. So lots of gardens have a CAD system with some kind of base map that shows where their plants are, shows where their hardscape features are. So that information is really easy to bring into the GIS and add a rich set of attributes to it. So CAD data generally doesn't have a lot of attribute information tied to it. Or so you may have plants on the map, but you may just have a label on that map that says that's the accession number and that's the scientific name of that plant. But in a GIS, you can add lots of information tied to that. So you can have all sorts of detailed taxonomic information, source information, and really the sky's the limit. As we mentioned before, it's that non-spatial databases. So if you have a plant record system, you can bring that into your GIS and link it to points on the map, so you have access to all that information you might have in VGBase or some other plant record system available to you in the GIS. And as I mentioned before, GPS is a really major source of information. So if you need to go out and collect features on the ground, you can't see them in your aerial photograph to a reasonable level of accuracy, and you want to map them really well, you can go out with GPS and collect data on those things. And then field sampling. So walking around the field with a mobile device or even just a clipboard, you can collect information out there, write it down, come back into the office and bring that information into your GIS. And then another really popular source of information is what we call remote sensing, which is essentially gathering information about an object without touching it. So pictures are remote sensing. Satellites take images all the time that is considered remote sensing. So aerial photograph would be remote sensing, or you can get kind of all sorts of different thematic images from satellites that collect information in infrared and other parts of the electromagnetic spectrums that we can use really successfully in GIS. And then surveying is another popular one. So if GPS is not quite accurate enough and you're doing, say, a construction project and you need to have decimeter or better level accuracy for that project, you can go out and survey it and bring that information into the GIS. So all this information is used in lots of different ways in lots of different industries. So emergency services use GIS to be able to route service vehicles to the locations and have information about where they're going before they get there. Environmental industry uses it for lots of monitoring and doing modeling, predict how things might happen in the future. Businesses use it all the time for being able to locate sites and deliver things. So UPS talks about logistics in their commercial. Well, their logistics is performed using GIS to be able to route those vehicles to their locations the most efficient way. Industries use it all the time. Transportation industry, maps of freeways and other road networks. Telecommunications uses it all the time to be able to plan the coverage of cell phone towers and things like that. Mining industry, pipelines, even healthcare. This image in the lower right-hand corner, GIS is used to map and store information about who's in what bed in their facility. Government is a really major user on all levels, local, state, and federal. Even the military uses it to be able to plan missions. And then education. It's a great education tool to be able to teach people how to about a particular thing. So research, teaching, things like that. Okay, so without further ado, actually, do you guys have any questions about that at this point? All right. So without further ado, what we're going to do is basically do a little introduction to the Esri ArcGIS desktop software. So we'll get started right away with that, and I'll start doing the live demo portion of the show here. And if you guys grab your mouse, we're going to open up ArcGIS desktop by going to the Start menu, and then going to All Programs. And as you scroll down, you should see ArcGIS. And then when you open that, we're going to open up ArcMap 10. So as we go through this workshop, I'll try to wait for most everybody to complete a particular step, and the easiest way for me to tell that you've caught up or you've got something done is just make eye contact with me. So when you're done doing a particular step, look up here, and then I'll know that we're okay to move on. Or you can nod your head or whatever, jump up and down, whatever works for you. Okay, so when ArcMap opens up, you may or may not see the screen. You can click in the lower left-hand corner not to show this dialog in the feature, and that's fine. We're generally going to start with a blank map every time, and that's one of the things that this lets us do. So how many of you see this box that I have up here? You guys see the Getting Started box? Everybody? Okay, good. So when that comes up, just select Blank Map and hit OK. And now, basically, this program is laid out with a couple of main features. On the left-hand side, you'll see what's called a table of contents. And this will list all of our different layers of information. So I mentioned that you can combine data from lots of different sources in ArcGIS and lay them over top of one another. So you could have a layer of an aerial photograph, which might be your bottom layer. And then on top of that, you may have roads, and on top of that, you may have your plants and different things. So you can have all those things available as layers that you can adjust the order of to see which one draws on top of another. And then you can also turn layers on and off as you please. And then the main window here, the right content pane here, is kind of the data frame is one way to talk about it. It's really where all your information is going to be displayed. And then you've got your traditional kind of set of menus at the top that you're used to for most of your other Windows programs. And then there's lots of different toolbars with lots of different buttons. And if you go to the Customize menu here and Toolbars, you can see that there's this enormous list of different toolbars that are basically put together, and each one has a different function. And most of them are pretty aptly named. So if you're going to look to do a particular task, you may need to open this toolbar to find out or to figure out what you're doing. And now this is basically, we're looking at things in data view right now. So this is one particular view into the information that you have. But if you go to the view menu, you can switch to layout view. And this will show us kind of like our page layout. So this is as you would see the output as it came out of the system. So if you were creating a map, you can actually lay things out on the page, put them where they're going to put them where you'd like to, so that when you print it out or export it to a PDF or something like that, you get more of a what you see is what you get feel. And then new to ArcGIS 10, at the side is that we have these little tabs that if you hold your mouse open, it opens it up. So this particular one gives us the catalog view. So let's just look at all of our different data and how it's organized on our computer. There's also one for searching. So you can search for particular things. So you can search, you can see that there's shortcuts here at the top for maps, data, or tools. You can essentially search for anything GIS on your computer through this. So it's pretty handy if you need to find a tool to do a particular task. You could type it in here, and hopefully that task will be able to produce some kind of result from you that you can click on and go to. So, and there's a few of these other tabs that we'll get into later. So one thing that I forgot to mention is that ArcGIS is made up of multiple different programs. So ArcGIS Desktop is made up of ArcMap, which is the main one that you're going to use most of the time. But if you go to the Start menu again here, go back to All Programs, and go to ArcGIS, you'll see that there's a few other programs in here that are part of the ArcGIS package. So ArcCatalog, which is, we can go ahead and click on that. Let's just take a look at that. ArcCatalog, as I mentioned, is through this catalog view in ArcMap, is basically the program that you would use to organize and maintain our data. And it's set up in kind of a similar way where we have kind of a table of contents, or what they call the catalog tree on the left-hand side, and then kind of a content pane on the right-hand side when you actually can see inside of things. So if we go in here, basically we have to create connections to the data that we have on our computer. So on the left-hand side in the catalog tree, under folder connections, you'll see right now that you may have a connection to the iDrive. Do you guys have that? Either way, it doesn't really matter. We need to create a connection to where our data is stored on this computer. So under the Edit menu at the top here, you'll see this Connect to Folder button. If you click on that, it brings up kind of the folder view of the computer. If we expand Computer, and then we're going to click on thaw space 0 or T drive. If you click on that and we hit OK, it will connect to that folder. And this is going to be where we're going to save all the data that we're going to work with today. Apparently, I didn't copy myself the data, so I have to do that really quick. You guys should see something. You guys see something called Arnold Arboretum on there? Okay, good. Let me just copy it to my own computer. The T drive is wherever you copied it to. That's what I want to make a folder connection to. Do you need one of these? Okay. So after you've made this connection to the T drive, you should just see in the contents pane Arnold Arboretum map package. Is there anybody who is not seeing that? Okay, we'll give them just a second to catch up. What this file is basically a new feature in ArcGIS is you can take all the information that you have in your map and compress it down to one file that you can distribute to other people. So for the last few months, or about 8 months or so, I've been working at the Arnold Arboretum to create a GIS for them based off of the data model that we're going to be working with today. And I've taken that GIS and I've zipped it up into this little map package file, and we're going to open it up and we can take a look at how the Arnold Arboretum is put their GIS together. You guys, you want me to wait a little bit, Mia?
Yeah.
Okay. Anybody have any questions at this point? The T drive. It's called thaw space. Mm-hmm. If anybody gets behind or feels like I'm going too fast, just raise your hand. I want to make sure that everybody gets this and it all makes sense. So. And I'd like to make a disclaimer at this point. Anytime we're working with computer technology, anything can go wrong at any time. So something will go seriously wrong at some point today. I can almost guarantee it. So let's put that out there right now.
So once we connect to this, then like in the future, like if this was a real project we're working on, would this always be connected?
It'll always be there, yeah.
The first step to kind of get.
Yeah, it's kind of like this little step of creating a folder connection is kind of like wherever you're going to store your GIS data on your computer, you create a connection to it, and then it will always be there. And it's kind of like a shortcut to be able to go back to that spot really quick. So today, this T drive will be where we store all of our data. We're going to go to the internet, we'll download some things, and we'll store them all there, so everything will show up nice and condensed for us here. Okay, are we all caught up? All right. So I think what we can do now is let's double click on this Arnold Arboretum thing. Oh, it might not open from here. I may have to do this on the, oh yeah, there we go. If you right click on it, you can hit unpack. Oh, error reading package contents. Awesome. See, I already told you something's going to go wrong. We'll do this the old-fashioned way. If you guys go to down on your taskbar here, you should have the Windows Explorer icon. Looks like a folder. Let's open that up. And then on the left, you should see thaw space 0, the T drive. Click on that. And then let's double click on this Arnold Arboretum. Oh, awesome. Not working. Super. Is it working for anybody? No. What version of ArcGIS do we have? I bet you that's the problem. Super. Let me just check something really quick. Please hold. Yeah, the service pack didn't get installed. That's what we needed. Well, let's see. Is the Missouri Garden, Missouri Botanic Garden thing on there still?
Yeah.
Let's.
I don't know if it's on everyone though, but I've seen it on a lot.
That one should open. Let's try that one. I don't have it anymore, but do you guys see a Missouri Garden or Missouri Botanic Garden file on there? You should try to double click on that one, see if that one works. Yeah, we can copy it onto there. Is there anybody who doesn't have the Missouri Garden one? Okay, we're going to copy it on here and then we'll distribute it. Did it open for anybody? Okay, good. Backup's always a good idea. So one thing, the problem that we're having and the reason that this isn't open is because the version of the software that I created this file with is not the same as what's on this computer, which is a common thing that can happen. So essentially we're missing service pack too. But so that's one thing to keep in mind if you're ever trying to share data is that the, so one thing to keep in mind is that the version of the software matters if you're ever trying to, collaborate with somebody. It's always a good question to ask first is what version of ArcGIS are you using?
So do you know where it is on this machine?
What's that?
The Missouri stuff, is it on this machine?
Oh, no, it's on here though, right? Yeah. I'm going to need to update the software if we can. Okay. All right, so we'll work to make sure that everybody gets this file, and hopefully it will open. So far, so good. All right, good. Works on mine. Now, how many people got this to open up to ArcMap when we... Actually, raise your hand if you didn't get it to open up. Yours didn't open? Okay. We'll hold here for just a second while we get caught up. So this file, this is obviously it's not the Arnold Arboretum. It's the Missouri Botanic Garden, and this is some GIS data that they shared with us. That this doesn't use the ArcGIS public garden data model we'll be working through today, but it does show you. Basically, we'll use it as a way to look around ArcGIS and explore the data a little bit and learn how things work. Who still needs the data? You do, and you guys do in the back.
So now you're open.
Well,
I got the data from Leo, so that's what you're getting on everyone else. There you go.
All right, we're getting there. Thank you. Oh, you did?
Just yesterday I left my pen case on the plane with like 2 flash drives and my pen.
Ooh. I think the last time I was with you, you lost your pen case.
I just lost one, like, on the train.
Yeah. All right, I think we're almost there. You're all set now? Okay, good. All right, so I'm gonna slowly move forward here. So you should see now on the left-hand side we have this list of different layers that are shown in this map, and you can, if you play around with these, if you turn things on and off like the reference grid, you'll see it go away in the data view over on the right. If you press the plus symbol next to these, it will show you basically what we call the symbology for this particular map. So under the base map one, you can see all these different colors, and then you have labels next to them as far as what this particular color represents on the map. So you can see that brown is structures, and those are the buildings that are represented on this base map here. Now additionally, besides all the map view of the data, there's the database kind of that's behind it that stores all the attribute information for this particular map. So if we click on the base map layer here and we right click on it, it'll bring up a context menu here, and 3 things from the top. There's open attribute table. If you click on that, it opens up this table, which is very similar to a view that you would be used to seeing in a regular database. You got your standard rows and columns, and in this you can see the tops of the columns. You have different labels for what these different fields in the table have in them. So there's always an ID number, which is a unique identifier for each record in this particular table. And then there's a field called base map type that has basically all these different types of features that are in here. And all of the information from this type is represented here in the list of symbology on the side. So you can see that there's landscape structure, and that's the first one on that list. So that's how this particular map is categorized. There's a field for name for a particular feature. There's a field for a description, comments. And then there's always in GIS fields for length and area. So if something is a polygon, or drawn as a polygon on the map, it will have a length associated with it and an area, which is pretty handy if you want to be able to calculate the area of, say, a garden, or you're trying to figure out how much mulch you're going to put down in a particular area. GIS can figure that out really quick for you. And there's some other fields in this. But the main point here is that there is this table view of information that's behind every feature on the map. So another thing that's good to take a look at is if you double click on a particular layer in the table of contents, it opens up the properties of that particular feature, and there's all these different tabs for lots of different information associated with this. So in the General tab, you'll see the first tab on the left, you'll see a name of the layer. You can type in a description for it. You can type in credits for who's worked on that. You can adjust the scale that this particular layer draws at. So as you zoom in and out, you can make it so that something that's really detailed, like your plants, where you may have thousands to tens of thousands of these plant dots on the map. You may not want to see those when you're zoomed way out because it would just kind of cover the whole map. So you can adjust the scale here so features only show when you're zoomed in to a certain level. On the Source tab, there's information about the extent of this particular feature class, so how far out on the map is it drawing. There's information about where the data is actually stored on your computer. Information about the coordinate system. So a quick couple words about coordinate systems is that the Earth being a round surface, we've had to come up with lots of different ways to turn it into a flat surface or represent it. So anytime you're taking something that's spherical and trying to flatten it out, you can do it in lots of different ways, but there's always going to be some kind of distortion in it. So there are different coordinate systems for looking at maps that preserve area. So if you wanted to look at things and be able to measure areas on it, you would use a certain kind of coordinate system or projection. If you're more interested in preserving the actual shape of something, then you would use a different one. So a good example is when you look at a map of the world, Antarctica and Greenland always look giant on most maps. But you can use a different projection that would make them look their actual size, but the map would actually be curved. So there's lots of different things, and you've probably seen them as you've looked at different maps throughout your course of your life. But so there's lots of different ways to do it. But what you guys need to know is about what coordinate system or projection you would be using at your own garden. And the most common one is called a state plane system. And as you're looking at this box here, you can see where it says projected coordinate system. You can see highlighting the actual name of the coordinate system, and you can see that it has state plane in it. And each state has one or more of these different systems associated with them. And the easiest way to find out what to use at your garden is to talk to somebody else who's using GIS in your area. So I usually say like the city or the county is a good spot. So you can call them up, talk to the planning department or the GIS department if they have one, and ask them. It's like, hey, what coordinate system do you guys use? They'll tell it to you, write it down, and then you'll put it into your system in a step that we're going to go through later, and then you won't have to really worry about it again. So there's lots of these different ones out there, and I just wanted to mention a couple things about it. Does anybody have any questions on that?
So you have to set that for everything that you bring.
Yeah, so we'll go through a step today that will basically assign a coordinate system to the data model, and then once we do that step, generally you don't have to worry about it again unless you're getting data from some other source and it's not in that system. You have to do a step called projecting, which will actually go through and change it from maybe that curved view to the flat view or whatever. So we'll talk a little bit more about that. Some other tabs in this window here that are interesting. The display tab, you can go to this and you can set the transparency on this particular layer. So sometimes maybe you want to have two things on top of one another, but you want to see through the top one to the bottom one. You can set percent transparency, which is kind of a neat thing to do. The symbology tab, this is probably one of the most important ones. This is how you decide how things look on the map. So you can take the different fields that are in our table that we looked at, the attribute table, and you can select to kind of categorize the colors on your map based on different fields in that. So right now we have the base map type field that we looked at in that table, and all the different values from here are represented, and then you can assign different colors to those. And we'll play a little bit more with that during our map making step later today. The Fields tab shows you a list of the different fields that are in that table, and as you click on them, you can see different properties from them show up on the right, and we'll play with that a little bit more later too. The Labels tab, this one is you can set things up on the map to label. So in the case of your plants, you might want to go through and pick the scientific name field and have that show up for each point on your map. So we'll play with that again a little bit more later, but there's all sorts of different options you can do for labeling things on the map. And those are probably the main ones that we need to take a look at today. Let's see, what else did I want to talk about here? I think that's the most of it. Is there anybody have any questions about this stuff? Oh, you know what? Let's zoom in and look at this stuff a little bit. So some of the other tools we should look at here. On your toolbars can be arranged in lots of different ways. So I may not be able to tell you exactly where a tool is, but on this particular toolbar here, you guys see this one? There's a magnifying glass with a plus on it. Okay. Grab that, and then similar to other programs you may have used, you can click and drag a rectangle on the screen, and that's where the program will zoom into. So you can zoom in and you can explore the data using these tools. Similar to the plus tool, there's the minus magnifier glass. You can zoom out. The pan tool, the hand, is a pretty handy one. You grab that. You can click on the map and pan around and move to different spots in your map. And then the one that's the globe icon, if you click on that, it zooms all the way back out to the maximum extent of your data. The ones next to that, there's a fixed zoom in and a fixed zoom out. You can click on those and they'll zoom in at regular intervals. Sometimes it's better than using the magnifying glass. And then as you zoom in and out, you'll see this box appear with the white box of the drop down. This is the scale box, and it's showing you the scale that you're currently at. So right now I'm at 1 to 3,000, but I could go in here and I could type in 6,000, and it changes the scale on my map. Now, one thing this is really handy for is if you want to make a map that is to scale. So if you wanted to print something out and you wanted a scale on your map that is maybe 1 inch equals 20 feet on the ground, you could type that in here by just type in 240. So this is basically saying it's a ratio. So it's 1 to 1. So 1 foot equals 1 foot. But I want my 1 inch on my map to be equal to 240 inches, which is the same as 20 feet. If I click on that, now I'm at that scale. And when I print this map out, you could actually use a ruler on it to be able to measure things. And this can be handy as if you want to be able to, say you're going to go out and design a new planting and you're out in the field. You can print out a map that's to scale, draw things in, and then you're getting a pretty good approximation of what the area of that particular planting is going to be, the actual spacing of the plants. You can do things to scale, so it's pretty handy. Any questions on this stuff at this point? All right. So the next thing we're going to do we have the recording happening? No. Okay. We're just going to go with it. All right. So now I want to talk a little bit about the Geodatabase. Okay, so the Geodatabase is the storage format that we're going to be working with today for storing our GIS information. But I want to talk a little bit about the data model project that we've been working on for the past few years and that you guys are going to be working with today. So when we started the project, we kind of went into it with this idea of enterprise GIS, which is the idea of using GIS not just to manage your plant collections, it's to manage all different facets of operating your organization. So you could use GIS for, as we mentioned earlier, for emergency response kind of stuff. So being that a lot of us are public landscapes, we have to have plans in place for being able to get visitors out in case of emergency. So you could use a GIS to be able to, figure that plan out and route people. You can use it for project management, and you're putting in some kind of new exhibit or working on a particular research project. You can use GIS to map that area, store information on it, things like that. Customer service, in our cases, is kind of visitor services, really, to be able to create tour guides and maps of, say, what's in bloom, things like that. You could use GIS to do that. Engineering for new projects, all that information can be stored in the GIS. Being able to do things mobilely. ArcGIS has the mobile component that we're going to work with a little bit later that makes it really easy to take the information that you have on your desktop out in the field with you, so you can have access to all that rich information while you're walking around out in the field, and that can be pretty handy. One of the ones I like is work order management. So you can set up different systems for dealing with work orders. So say you have someone is out in the field with their mobile device or their cell phone, and there was a storm and this tree has come down, and they can basically take their mobile device, it knows where they are based on the little GPS unit that may be included with it or one that they have with them. And you could click on that particular area and say, hey, there's a tree down. It will go back, send that information back to the office, and the landscape department would get that work order and know that they need to go out and take care of that right away. And that can go to many different levels, and there's lots of use for doing that. Operations is another great one. Site selection, being able to find the ideal spot for something. So if you have a particular plant that is very sensitive, obviously, our firsthand knowledge of the landscape is probably the best way to go, but sometimes you may want to know what your options are, and the GIS can produce that for you. I need something that has a north-facing slope, that gets afternoon shade, that has good soil drainage, has this particular soil type, all those different things. You could use the GIS to be able to identify the ideal spots for that plant. And I think probably the most common use of the GIS is for asset management. In our case, our plants are our main asset. But we also have things like commemorative features out in the landscape. We have all of our facilities that we want to be able to keep track of and store information on. So the GIS is really good for doing that. So this was kind of the concept when we were designing data models. Like, we want to make it able to do all of these different things. So, excuse me. So what is a data model? This quote here at the top of this slide is the official definition of it. But essentially, a data model is really just a database schema or database design. So what tables do you have in your database? What fields do each of those tables have in them? And how are they related to one another? That's really what the data model is. So right now there's over 30 different data models for ArcGIS for different industries. So the forestry industry has one. The oil pipeline industry has one. The people who are doing biodiversity conservation, they have one. So this is just another one in a long line of different data models. Another good way to think about it is that the data model is really a template or starting point for your GIS project. So the way that we've designed the model is that it's a free and open source thing, so you're free to modify it all you want. So it gives you a starting point. You don't have to go through and think, well, how do I want to be able to, relate things together, or what information do I really need to store about that? We've done a lot of that groundwork for you guys so that you can download this thing and get started without having to essentially reinvent the wheel. But the cool part is that if it doesn't have what you need in it, you're free to modify that to your heart's content. So if we don't have fields in there for something that you want to track, you can quickly add those in there and get going with that. So the goals of the project were to make it free and open source. Free, that you can download it and don't have to pay a penny for it, and open source, and that you're free to modify it. And we wanted to make sure that it was able to suit the needs of all different kinds of gardens. So we realized that there's lots of small gardens out there that would like to use it, that have one person that is working maybe just a few hours a week on this particular project. But then there's also gardens like the Arnold Arboretum or Missouri Botanic Garden or the San Diego Zoo, who we wanted to be able to make sure that it suited their needs as well as a large organization. So we basically tried to make it a modular system so that you can use little bits and pieces of it and delete other parts that you don't need if you'd like to. And because when we started working with this idea of enterprise GIS, we tried to focus on the features that were going to provide the greatest benefit, because gardens can kind of be like miniature cities. Essentially, we have all the same things to worry about. We have utility systems, we have roads, we have buildings, all these different things that you may want to at some point include in the GIS, but we knew with the project's funding that we had to do this that we weren't going to be able to do all of that stuff. So we tried to focus on the things that we thought were going to get the most use. And an important thing to know is that we've designed the model to work with existing plant record systems and not replace them. So if you're using something like GBase, which is incredibly comprehensive in what information you can put into it, we weren't trying to reinvent the wheel or replace that, but instead we're trying to make it so that you can link things together. So if you have a plant, a dot on the map for your plants, we store a basic set of information in the GIS that is required to make your collection maps, but not too much else. The idea is that you can create a link between those two and that you can pull in that information from a plant record system you already have based on some kind of link. So a lot of times that might be the accession number is your link. But whatever it is, you can link that information together, and we'll discuss that a little bit later today. So, like I said, designing the model was kind of like modeling an entire city. We had all those different things. to consider. So we did a survey at the beginning of the project, which you may or may not have seen, to basically figure out what were the things that were most important to botanic gardens. And that survey came back with saying that obviously plants are going to be one of the most important things in there. Secondarily is what we call the base map, which is kind of what we were looking at there with that Missouri Botanic Garden data set. It's kind of like all the background stuff that you'd expect to see on a map. So if you're producing a collection map, you want more than just your plants. You want your sidewalks, your buildings, planting beds, things like that in there. So that came back as the second most important thing. And then third was facilities and infrastructure. So buildings, roads, all that kind of infrastructure stuff that makes our gardens go. We needed to have all that in there as well. So we created a base map and facilities and infrastructure components to the data model, and then a basic plant collections or plant records module that works with plant record systems, as I mentioned. And there's currently well over 150 objects in the model, and that just means really that there's lots of different things that you can map. We have lots of things included. The slide's duplicated. So a little bit about the Geodatabase. So as I mentioned, the Geodatabase is you can think of it as a container to store all of your GIS information on your computer. But inside that container, you can have lots of different things. So I want to lay down some terminology here that we're going to be kind of using repeatedly today, and hopefully it will slowly start to gel for you as the course of the day goes on. The main building block of the Geodatabase is what we call a feature class. And feature classes there's different types of them. There's one for mapping point features, which would be things like plants. There's one for mapping line features, which would be things like walls, fences, things like that. And then there's one for polygon features, which are things like maybe buildings or like lakes, things like that you want to map with a polygon. And then there's a fourth one for annotation, which you can think of as labels. So if you have text on your map, you can store that in a feature class so that you want to pull up your plant labels, you can do that really quickly. There's also a table, and a table can be thought of as the same thing as a feature class, except it doesn't contain anything on the map. It doesn't contain any spatial data. So a table is what you'd have in your your normal database systems. So you may have your plant record system. You want to open up your table on your accessions. So that kind of information you would store in a table. And each one of those things, feature classes and tables, can both have what we call subtypes, and it's kind of a finer grained definition. So for point features, or for plants, for instance, you may have two different types. You may have one for an individual plant, or you may have another type for one that is part of what we call a mass planting, or a group of plants that you don't want to map as individuals. Another example would be for line features for, say, streams. If you have different streams on your site, you may have a different type for one that flows all year round and one that only flows for part of the year. So this is kind of a way to add finer grain organization to the information in your map. And it looks like I lost some information here, but feature classes, and this diagram on the right-hand side, and I don't expect you guys to be able to read this, but what this diagram is this comes from our data model poster that basically shows all the different things in the data model and can be used. You guys can download that with the model and use it for reference. But it's all color-coded based on these different things. So feature classes are what's represented in blue, and tables are also represented in blue. And then there's the green things on here are relationships, and those are things that are built between two different feature classes or tables. So you may have something on a map where maybe your plants or your plant centers are related to a mass planting. So if you have a group of plants, you've drawn a line around this group of plants that are really complex, and it has 5 species inside of it. You would have 5 different points for each of those different species in there, and you want to relate those things together so that when you click on the polygon, you get all the different points that are inside of it. Another example might be is that your property for your garden, you've divided that property up into 6 or 7 or 20 different gardens that have different names, different parts of your property. So when you click on that property, you want to know that all the gardens that are related to it. So it's a way of kind of linking information together to get a little bit more meaning at it. And we'll explore that in a lot greater detail. So it's okay if you're not quite getting it at this point. And then there's a thing called a topology, which is represented in orange. And a topology is basically a set of rules that we've set up that kind of guide the quality of the data or help maintain the quality of the data as things go on. So as you're drawing in things today, you may draw by accident, you may draw it so that your sidewalks overlap a planting bed. And we've set up rules in the data model so that we'll go through and automatically find those errors and say, hey, your sidewalk is you drew it kind of sloppy and it went over this planting bed. Here's where you messed up. Go back and fix it. So there's lots of those things that are built into the data model to make our lives a little bit easier. And then there's another thing called a featured data set, which is in purple on the map or on this diagram here. And those are basically groups of things that have something in common. So if there are, your sidewalks and your planting beds, you don't want those to overlap, and you want to create that kind of rule between those. We put those into the same feature data set, and that's probably the least important out of all these things. So don't worry about that one too much. And then finally, there's what we call domains, which are symbolized usually in red. And a domain is basically a list of kind of valid values for a particular field. So if you want to have a field that the only things you can put in it are yes or no, you can create that list ahead of time to make it easier so that when you're entering data, you get a little drop down and it just says yes or no. And we have lots of these defined for the data model, and we'll create one today for some scientific names so that when we go out in the field, instead of having to type in the entire scientific name of a plant, we can select it from a drop-down list, which can be really handy. So I think that's the last component of interest. So I'll be mentioning these terms today as we go along, and I'll try to explain them a little bit more as we go. Are there any questions on that so far? All right. So this thing, again, don't expect you to read it. But I wanted to show you that we have this poster that has all sorts of information on it on how the data model is organized, and we'll look at it a little bit in greater detail. But here we've got, these are all the different objects of the feature classes and relationships that are in our data model. And then we've zoomed into these things in greater detail here, and you can see all the different fields that are associated with it. There's domains of lists of values, the relationships between them. And then we have a list of different layers that you would have in your ArcMap table of contents that you can turn on and off, and lots of different things. So this is available as a reference just so that you can figure things out and how we've designed things as you're working with the data model. So to look at this stuff in a little bit greater detail, hold on for just a second. I realize I have a pointer to be able to help out doing this stuff. I'll show you a little bit how the data model is organized here. If I left this on, we'll see if it works. Oh, it does. Good. Okay, so as we mentioned earlier, we have feature classes in the data model, and those are in blue, right? So in this particular example, we have sections, which we've defined as smaller administrative boundaries for the garden. So sections might be like in our case at the UC Davis Arboretum, we have a California natives garden, and we have a redwood section. So we have these different sections of the gardens that we've named, and they have kind of boundaries that you'd be aware of. So in this particular case, we have sections of our garden have structures associated with them. So you can click on a particular section in the garden, say our California native garden, and in that garden, we may have several buildings. So those buildings would all come up on the map when you click on this section. And I'll show you some examples of that. So sections have structures associated with them. And structures may have enclosures. In the case of a zoo, that building may have animal enclosures inside of it. So we want to know what animal enclosures do we have inside this building. And those relationships are all set up so that when you click on this section, you can see what buildings are there and then what animal enclosures are inside of it. And this particular structure also may have entrances and exits. So you may want to know, how do I get in and out of this building? We got an emergency, and we need to be able to know, where are the entrances and exits? What key do we need to open that? Who do I get a hold of if I need to get that key? So all that kind of information we can store in there. And then additionally, we have this structure may have contact information associated with it. So you can have a contact record associated with that. So you can have the phone number and the name of that person to call in the case of emergency. So that's basically, this is kind of how these things are related inside the Geodatabase. If we zoom in on the structures object here, so if we're zooming in on this guy, this is what the table would actually look like that's behind that particular feature. So now we can see that it is a polygon feature class, and here's all the fields that are in this particular feature class. So we've got an ID field. We have a type of building. What type is it? Is it an administrative building? Is it a research building? Is it an education building? Or all those functions in there. It's got a name and has an address. When was it built? Sometimes people are interested in how long is that building expected to last for. If you have blueprints for that building and you have them digitized and on your computer, you can link to those so that when you're click on that building on the map, you can quickly bring up the blueprints for it really easily. We've got, how many levels does it have? The presence of utilities. So does it have water? Does it have gas? Does it have telephone? Does it have data? Does it have a sewer system? Heating, cooling, fire suppression, all that stuff's in there. Is it ADA accessible? So is it handicap accessible? You can put that in there. And lots of different stuff. And then on the side here, you can see that we've got in red, as I mentioned, the domains are in red. So we have a domain for this particular feature class, which is called yes, no. And you can see that all these utility systems have that domain assigned to it here. So basically what that means is that when you go to enter data into this utility gas field, the only options you have are yes or no. So does this building have gas or does it not? And that's the basic idea. And then there's a little information about the relationships that it participates in. So one thing to know about relationships is that they can come in different types. So there can be a one-to-one relationship, so that when you click on one thing, it has just one other feature associated with it. But there's also a one-to-many. So in the case of contact information, maybe you have this structure may have multiple contacts. So you can have so it's a one-to-many relationship, saying that we can have more than one, and we don't have to worry about that too much today. Are there any questions on that so far? All right. Break time.
I'd like to do our first drawing here. So let me do our prizes. You see, we have a lot of people who use Creamery, Gary Creamery. We have a new, within the College of Ag and Natural Resources, new Creamery that uses cows, milk from cows from UD farm. So this is one of the prizes it has. I'm also using it as a straw. So we have this insulated carrying bag, a thermal bag here. Coffee mug. We have two different sets of 2 tickets to Longer Gardens for free admission. We have a Creamery t-shirt, large. And we have 2 plants from the University of Delaware Botanic Gardens. One is it's called Begonia Lime Squirrel, which is this one, and the other is called Begonia Fireworks. These are both rhizomatous begonias, so I've put some care information here. So all right, last 3 digits, 609.
Nice. Yeah. Go for the plants.
All right. Thanks. We'll come back from break at, how long do you think?
15?
15 minutes?
Yeah.
25?
Yeah, so if you guys need to use the bathroom or grab a bite to eat,